Hello friends, this is Eli from Mystic Circuits. Today I will be showing you how to build the 0 HP VCA AND gate. This one differs from our Vactrol VCA in a couple of ways. First of all, the voltage control works up to audio rate. So you can do amplitude modulation sorts of things with this, and also it works much better as an actual AND gate, allowing you to mute a series of gates with a second stream of gates with a second stream of gates, but comes with a couple downsides. The first is that the signal loss is greater through it, and also there's some distortion that happens as you're opening and closing the VCA. I quite like the distortion, but in some cases you want a nice clean signal, and this one will not do that for you. So this is one of our more complicated kits. It's not the worst, but it definitely is more involved than a lot of the other kits that I've filmed so far. So we're going to go ahead and open up our kit, make sure that everything is hopefully inside. First thing that you'll see when you open it up is the instruction booklet. If you are fairly experienced building kits, this should be enough to get you there. Just going down the list, following the instructions. There's this QR code. This QR code is possibly how you found this video. It will also take you to a more lengthy written manual with pictures and step-by-step instructions to do the kit if you would like to follow along in more than one way. We're going to put the instructions to the side for now. And we're going to look at our bag of passive components. You should see 4 1K resistors, 2 1 meg resistors, and 1 10 nanofarad capacitor, that being the little orange blob. Don't worry about double checking these values. Just make sure that there's 4 resistors in this group, 2 resistors in this group, and 1 little orange blob down here, right? Next, we'll be looking at the active components. You might either have the bag taped to a piece of paper, or the piece of paper might be inside the bag. But we're going to take off the bag, and you'll see it kind of gives you an idea of what to expect in there. You're going to have 1 H11F1 and 1 LED. So if we take everything out of the bag, we have the LED right here, and the H11F1, which is this white chip, is up here. Now, it should be pretty easy to tell. It's very rare to get white ICs, and this one has 6 pins, which is also quite rare. So if you have just verified that those are there, we'll go ahead and just keep everything in frame so that we can see all of the parts together. And we'll finish up by opening up this other bag. This has all of the hardware as well as the circuit board and the case components. Right now, we're going to go ahead and sort these out. Here we have the circuit board. This is obviously the most important part of the design to have. We also have a lid and bottom for our case. You might see the filter. We use 2 sides to every lid. Now, there are some of our short sides which have these little holes in them. You should have 2 of those, and 2 long sides. There will be 4 jacks, 4 rubber feet, 4 bolts, and 4 nuts. All right, so once you've verified that you have all of these parts, go ahead and take the case hardware, put it to the side. I'm going to do this. We won't be needing it for a little bit, all right? So let's take a look at our circuit board. So you'll see here that we have a couple of different resistor values on the board, right? We have each one of these little circles with the white line sticking off of it between these 2 points is a resistor, right? The white line indicates where the resistor is going to connect. And you see some of them say 1K, some of them say 1M. It's important to get this right because the 1M resistors are about 1,000 times more resistive, right? Meaning that they let through 1,000 times less current. And so if you use these 1M resistors somewhere that you're supposed to have a 1K resistor, you're not going to hear very much coming out of it. All right. So what we're going to do first, I'm going to put these active components to the side. And we're going to look at our paper with the passive components. We're going to do the 1M resistors first, just to make sure that everything looks good. I'm going to take them out of the paper. Take the little pieces of paper off the side. You should see 2 of them. They have a little yellow line across their middle. And we're going to take them, hold it by the body, flip it over to do a little U-turn so that it looks like this. All right. And we're going to find the 2 footprints that say 1M. That would be the one all the way on the top to the right of our board. If we're reading all of the text, don't build it like this because it's going to look different from what I'm doing, right? Make sure that your circuit board is in the same orientation as mine. It'll make it a lot easier to follow this. So 1M up at the top here. I'm going to put the body with the longer leg through where the white circle is and the short leg through on the other side. Don't worry if you do this backwards. I just like the way that it looks better like this. So now our resistor's sticking all the way through, but it's not going to stay still if we keep flipping our board over and doing stuff like this. So what we're going to do is we're going to hold our finger on top, push it into the board as far as it'll go, without applying a bunch of force. But we're going to bend these legs over in order to make sure that that resistor isn't going to move anywhere while we're doing the rest of our work. All right. So now I'm going to do the same thing with this other resistor, bend it all the way over, right, into a little U shape. We're going to look at this bottom corner. I'm going to put the long leg into this circle, as I said, just for fun, and the short leg into the other pin next to it that says 1M. All right. And then we're going to bend our legs in other directions. All right. I'm going to kind of move these legs around once we're getting ready to solder, just to make it easy to avoid adjacent points. And I think for a board that's both expecting you to be a little bit more advanced and also where there are all these pins that are next to each other, I think we're going to have an easier time if we solder all of the resistors at once. So before we go to the next batch of resistors, go ahead and make sure that both of the resistors you just put in are next to the 1M symbol in the lower right corner and the upper right corner, right? All the way to the extremes of the board. All right. So now we're going to take our group of 1K resistors. We're going to take off the paper from both sides. And we are going to do the same thing, a little U-turn shape. Place them into all of the positions that say 1K. So here, bend out the legs. Here. Bend the legs. Place it in the board. Bend legs. Here. Bend legs. Here. Bend legs. All right. So first, just go ahead and take a look at your board. Make sure it looks like this. You don't want anything in this little capsule that says 10NF or this circle that says LED. You want all of the other sort of passive component positions to be occupied. All right. Make sure it looks roughly like what I am holding now before you start soldering. All right. And feel free to pause the video here just to confirm. And now we're going to flip things over. We see we have this big jumbled mess of legs. What we really don't want to do is what's happening with this leg, where we have the leg going over a bunch of other pins that could accidentally get solder in them. So I'm going to go ahead and rearrange some of these. Right, these ones all seem pretty good. It's mostly this one. So what I'm going to do is I'm going to send it kind of over in that direction, right? And now we have like a nice, easy access to all of these solder points without having to do a ton of bending things around. I might move this one a tiny bit too, right? And I'm going to go ahead and start soldering. So first thing we want to do is tin our tip. Again, I will have a video in the description with some quick tips for learning to solder. I would not suggest this as your first kit, but if you're doing it, it's good to watch that video. I give a lot of good safety tips as well as just some methods that I've learned. So don't use the tip of your iron, use the edge of your iron, place it against the leg, and press your solder in. There was no solder that ended up on that joint. It's kind of hard to see because the board is on the other side of a bunch of film equipment. I need a better tripod is really the thing. My tripod, you know, obviously it has the 3 legs. It makes it so that I can't really get super close to the thing that I'm filming when doing it at this angle, but I'm able to look on the monitor and just verify that everything looks the way that it should. I think instead of soldering these two, because there's this big leg going across, what I'm going to do first is I'm going to solder the legs on this side. And then I'll be able to move the leg out of the way. Just making sure it's flat because I saw it moving around while I was rearranging the board. Right? So now that that leg is soldered, I'm just going to take a quick look. Everything looks good. Wait a sec or two because the legs will stay hot even after the iron is gone. And now we're going to solder these points and do your best to not, in fact, we've already soldered this. So I'm going to move this leg that way, right? So that we can hopefully avoid getting any solder into this joint accidentally. It's going to make it way more annoying to get our jack in that position. I'm less concerned this time because my iron is on the other side of the joint. But just do your best not to get any solder into unpopulated holes. It's going to make it a lot more annoying to deal with later. And it looks like I just have these 2 legs left. Okay, so it looks like this leg down here did not take any solder on. Do it again. Sometimes you need to use a little bit of extra solder, especially on those points that look like a little cross. That indicates that they're connected to ground. You might have to turn up your heat a little bit on your iron if you don't feel the solder taking. And I'm just bending all of these legs to verify that nothing moves around when I bend it, and nothing on the actual blob of solder at the top of the board. We kind of wiggle each leg around and make sure that this blob that's actually attached to the board is not going anywhere. All right. Now I will cut the legs. Again, whenever I cut legs, I do my best to make sure that all of the force that's removing each leg is coming from the sides and not pulling upwards. All right. I'm noticing this ball of solder here is a bit bigger than I want it to be, so I'm just cutting off some of this extra solder. Just prevents accidental shorts and stuff like that. Don't worry if your solder doesn't look quite as slender and beautiful as mine. It shouldn't be a big deal, but yeah, we mostly just want to make sure that all of these joints are pretty close to the board, because you can accidentally short against the bottom of the board, which I of course made out of conductive material. This is on me. I'm replacing this shape with silkscreen layer in the next batch of bottoms that I'm about to order, but you know, just in case, go ahead and cut everything short on the bottom. Now we're going to take our capacitor right here, take it off of this sheet of paper, and we have the little capsule at the bottom that says 10 nanofarad. We're going to put our capacitor in there. All right, it should look like that. Hold it still and bend the legs in opposite directions. You can see here I bent this leg away so that it wouldn't be overlapping with that series of 3 pins. And then I'm going to take my LED from the active components. We're going to populate that at the same time too. All right, so you've got this line over here going towards your in jack. That is where the short leg of our LED is facing. If you do this backwards, your module won't work. All right, so again, short leg of the LED going to the right towards the in jack, and where this white line is going, double, triple check, rewind the video, do whatever you have to in order to make sure that you did this correctly. We're going to go ahead and bend the legs, and we're going to solder these parts. And in order to do this, I am, of course, going to do my favorite thing, which is tinning the tip of my iron. I do this before I start soldering. Every time I put my iron down, it's sometimes in the middle of soldering. It just makes things go a lot smoother. I'm doing it off screen to make sure it goes into my fume extractor. We're going to start with the LEDs because they're the longest, or the LED legs. Right? Soldering both sides. Wait a second and then bend this up just so that we have easier access to the capacitor legs. Everything appears correct. Now, I'm going to wiggle all of these legs, make sure these joints look good. I'm going to do this with my wire cutter. You can kind of use the cutters, if you're real gentle, as a plier. All right, now cut off these legs. All right. We have our board looking like this. This is what it should look like with everything but the jacks and the chip populated. All right. So now we're going to take our white IC, the H11F1, and we're going to make sure you should be able to see that dot in the upper left-hand corner. You see right there? That marks pin 1. All right. And whenever you see a little dot on an IC, it's going to mark pin 1 on our chip, which is going to face the top of our square. All right. Pin 1 is usually facing the side of the IC with the name of the IC on it. You can't follow that all the time, but this little curve in the square indicates the top of our IC. The circle indicates the top of our IC. Pin 1 is always going into the upper left-hand corner of our footprint. Make sure before you start soldering that everything looks like this. The dot on your IC facing the upper left-hand corner with the CV square jack. The jack will eventually go here for the CV. Upper left-hand corner is where you want that dot facing. If you do this wrong, once again, your board will not work. All right. And we're going to do something, a sort of advanced maneuver for soldering this in place. If you flip your board over right now, it will fall out. What we're going to do is we're going to hold with our pointer finger and then grab the circuit board with the adjacent fingers, with your thumb and your middle finger, right? So my thumb and middle finger are holding this almost like a coin. I'm making like a claw, right? And then my pointer finger is pressing onto the top of the IC so that I can hold everything in place at once. And then when you flip it over, everything is staying still. All right. Next, you're going to take your solder and you're going to make a little like fish hook kind of thing. I like to think about it as a cobra, right? I call this the cobra style soldering. And basically what it does is it makes it so that you can free up a hand. The solder will want to stay in place, right? If you don't have your solder in a spool, you can maybe use a clamp or a third arm tool to hold it still. But basically your solder is going to be floating in the air, right? I would have ideally tinned my solder before this whole thing, but I think I should be good enough to do this. Basically, I'm going to hit, just readjusting a little bit. I'm going to press my iron against this corner pin. Trying to get it in focus right here. You see that? And then I press the entire thing against my floating solder. And you can see if I just kind of press into it, I was able to melt the solder onto the pin, right? And now my whole chip is staying perfectly still. You should probably just double check that the chip is flat. If not, just heat up this pin again and press into it. Be careful, because if you heat up your pins too much, your chip will get hot and it might burn your fingies. So we're going to go ahead and solder the rest of these pins. I like to start with the opposite corner just to hold everything still. And then I'm going to go down the row. If you see me press some solder in and then pull away and there's no solder on the pin, it's because it's kind of hard to see these pins because I'm so far away from the board, but it looks like everything worked. I can see a little bit. There is some solder on this joint. You can see here, there is solder on this pad, but you can also see the pad underneath with a little tiny bit of the hole exposed, right? And you'll see too, this has the cross shape. That's because it's one of the ground pins, right? So we're going to go ahead and heat up the solder there again. Oh, that was disorienting. We're going to heat up that solder again just to make sure we've made a nice solid connection there. I'm going to warm up a couple of these whose shapes I don't like, just because sometimes that can cause problems. Okay. Now we have everything on here. Just to be on the safe side, I'm going to cut these pins. You don't need to cut a lot off, just like whatever excess is left on top. As I mentioned before, sometimes you can short against the bottom of your kit. And it doesn't hurt to kind of do this just to ensure that you haven't accidentally connected any pins together, or that there aren't like extra little blobs of solder sitting on your board that might eventually dislodge and then cause your board to stop working. But basically, you should be seeing something like this on the bottom, something like this on the top, right? Everything is looking good so far, so I'm going to go ahead and put in my jacks. Each jack has 3 pins. You'll notice each square or a jack has 3 holes. The part of the jack where the cable goes in is always facing the outside of the board. For some reason, these holes feel a little tight, so I can tell I'm going to have to kind of press into each jack just to ensure they're all flat. What you don't want is a jack that's kind of sitting up where you can see underneath the jack. You want your jack to be nice and flat against the board. Otherwise, it'll be hard to put on your case. All right, I can see here too, this jack is lifted up in the back a little bit. Less important, but still good, just to make sure everything is as flat as it possibly can be. And now we're going to solder this part. Go ahead and tin your iron. You might also have to raise the heat of your iron for this part, because these kinds of tabs usually require more time and heat to work. You can see how much longer it took to solder that joint than it did with the other ones. I'm going to move my fume extractor a little bit closer. I apologize for the black piece on the side. I just don't want my room to smell like solder. Or, you know, cancer or whatever. I mean, my understanding of solder safety is that the fumes usually are the least dangerous part. Sure, if you're soldering all the time, you can get asthma and stuff like that from the fume irritation, but that actually the thing that will possibly expose you to toxins is what ends up on your hands, right? The rosin. And the rosin is what's causing the smoke, right? You don't want to inhale it, but it's not the end of the world if you do. But what you really want to do after soldering is wash your hands, right? Especially if you're about to eat. I generally try to avoid finger foods on any day that I am doing a lot of soldering. All right. So those 8 pins have been soldered. You technically don't need to solder these other 4, but I'm going to do it anyways. And I suggest if you're at all unsure about which pins need to be soldered, just go ahead and solder these. It never hurts to get a little bit of extra practice soldering. Except if you've been soldering for 15 years, in which case you should be figuring out every single way that you can to do less soldering. That's why I'm selling these as kits now. Okay. So everything's looking good. I can't see any of the holes. You can see there's the little kind of mountain Hershey's Kiss shape of solder. I have been suggesting to cut the 6 pins that are closest to the center of the board because of the bridging possibilities. Again, I apologize for the extra work that this is making you do, but it's less work than trying to figure out why your board isn't working, right? So, whoa. That one was pretty short already. All right. All right, so again, it was these 6 pins. I suggest snipping off just the extra bit of metal that's sticking outside, and then this should be what your finished board looks like. All right, so now we're going to assemble the case. Zoom out for this. And we're going to take our case lid. We want if it says filter, go ahead and flip it over. We want the text on the circuit board and the text on the lid to be facing the same way. And you can also kind of see CV, CV, trig, trig, in, out, out. You want the labels on the actual jacks to match the labels on the board. Make sure that it's oriented correctly. The LED should be going through this little window. If you do that wrong, you might be confused as to why your board isn't working. So go ahead and make sure of that. Now we're going to take our short sides, and you can see each short side has a little tab. This is the top. You can tell because the jacks are closest to this side. Each one has a little tab on the top, and those will go into these holes on the bottom and the top of the lid. So we're going to go ahead and orient those tabs towards the holes, then place the lid on top. You'll sort of see the tab going through. And if you have to fight to do this, try turning one of the pieces upside down or seeing just what seems to be the problem. You should be looking at something roughly looking like this. It's good at this point to verify that your LED is in fact on the same side as this window. That's usually how I check that everything is oriented the right way before I finish building the case. So we have the lid and we have our long sides. I usually like my logo to be facing up as I am placing them in, and you'll sort of see all of the pieces come together into a little puzzle box kind of scenario, right? And if I place the case upside down, we can look at the bottom and make sure that the gaps, the little openings in the bottom, are aligned with the tabs coming out of the bottom of our sides. So go ahead and fit. I usually start with one side and then I go to the other and I grunt until everything has been placed in alignment. Sometimes it helps if you curse or scream out in pain. There we go. So now, case, yeah, and you might not have heard it, but there is sort of a characteristic snap that happens when all of it comes together, and everything's looking groovy. So what we're going to do now is we're going to take one of these bolts, put it through in one of the corners. It might go through easily, or you might have to work a little bit extra. If you are having a lot of difficulty with it, I suggest taking a screwdriver and kind of screwing it through. It'll help kind of align the parts and get it to the right point. What I just did now is I took the other side of the bolt, right? I took one of the rubber feet. There's a side that has a little cavity on it. You want that cavity to stick out so that you can put a nut into the cavity, all right? So it should look like this. Put your finger on top and then press gently towards the bolt and screw it tighter. You might have to kind of push to the side in order to make sure that the bolt is mating correctly with the nut. Screw in. Bolt, foot, nut, screw. Bolt. All right, there we go. Foot, nut, screw. There we go. Finished 0 HP and gate. Looking good. That's what the back should look like. Yeah, so that was one of our more advanced 0 HP modules. If you did it, Mazel tov. We'll go ahead and add a little bit to the end of this video in order to show you how to test and make sure that everything's working correctly. And thank you for watching. Okay, I'm going to go ahead and set up a little patch in order to test our 0 HP AND gate. A good place to start is to take an envelope. Here I have the Schlappy boundary. Turn it on. You should see your LED flashing. I might make it a little bit longer so you can see now our LED is working. Now I'm going to plug an audio signal into our input, which is going to just be a sawtooth, this time from the 3-body, and plug into the output. And you should hear your signal gradually being controlled in amplitude, right? And then just for good measure, go ahead and plug into the trig out. You should also hear the audio, but with the low end removed. And yeah, there you go. If all of this looks right, then you have a working 0 HP AND gate. If not, go ahead and leave a comment. I'll also link to a thread over on the forum, and you could also get in touch with me through the contact page of my website. I hope that this was a fun and successful build for you, and yeah, happy patching.